In this video we will look at finding the point of intersection of two lines, and we'll use two different methods. So for the first example, we would like to find the point of intersection of the line x plus y equals minus 2 and x minus 3y equals 18. So before doing any work, let's think about this from a geometric point of view. So if I want to sketch what these two lines look like, the first line would be y equals minus x minus 2. So it has slope minus 1, y-intercept minus 2. So roughly speaking, it looks something like this. The second line, this is minus 3y equals minus x plus 18. Dividing by minus 3, y is 1/3 x minus 6. So it has y-intercept minus 6, slope 1/3. So slowly increasing. And what we are attempting to find in this problem is the point of intersection. So the two equations that we have, x plus y equals minus 2, x minus 3y equals 18. So for this first example, we are going to use the method known as substitution. So we are going to solve for one variable in the first equation so that we have a quantity we can plug into the second equation. And since the x variable is easier to work with in the second equation, i.e. no coefficient, that's what I'm going to solve for. So x is equal to minus 2 minus y. And we're going to go ahead and plug this minus 2 minus y in for x, substitute it in. When we do that, our equation becomes minus 2 minus y minus 3y equals 18. So adding 2 to both sides makes the right side 20. On the left we have minus 4y. So y is 20 over minus 4, which is minus 5. To find the x-coordinate of the point of intersection, what we need to do is go back to either of our original equations. And in this case, what we're going to do is just plug in y equals minus 5. So this value that we have for y, we want to substitute that in. So x is equal to minus 2 minus the y value, which is minus 2 plus 5. So x is equal to 3. Putting this together, the coordinates of our point of intersection is the point 3 comma minus 5. And as a reminder, we can see this in our picture. It corresponds to the point where those two lines intersect. In this second example, we want to find the point of intersection of the lines 3x minus 4y equals 5 and 2x plus 3y equals 9. Now, in order to do so, in this second example, we are going to use the method which we have referred to as elimination when you have encountered in the past. The idea is to somehow get these coefficients such that when you add them together, one of the variables, either the x or the y, are going to cancel off. So in this example, what I'm seeing is that there's a negative coefficient of y in the first equation, positive in the second. So I can multiply these equations by a number and keep an equivalent equation. So for the top equation, I'm going to multiply by 3. In the bottom equation, I'm going to multiply by 4. And when I do so, my first equation becomes 9x minus 12y equals 15. Notice each and every part here was multiplied by 3. The second equation, when we multiply by 4, becomes 8x plus 12y equals 36. And once I have the two equations written in this form, what we would like to do is add them up. When I add up these two equations, you end up with 17x is equal to 36 plus 51, so that in this case x is equal to the number 3. And once we know the value of x, just as we did in the previous example, what we need to do is take that and plug it in to one of our original equations and solve. So let's go ahead and plug x equals 3 into that second equation. When we do so, we end up with 2 times 3 plus 3y equals 9. So 6 plus 3y is 9. Subtract 6 from both sides. 3y is equal to 3, so y is equal to 1. Putting this together, the x-coordinate of our point of intersection is 3, the y-coordinate of our point of intersection is 1. So to summarize, two methods that we can use to find the point of intersection of a line: substitution or elimination, and depending upon the form of the two equations that you have, one form may typically work better than the other.